Hi guys, for today's lesson we're going to be dealing with differentiation with fractional powers. So when you're differentiating functions with x under a root sign, and make sure this x is just a single term, we need to convert the expression to fractional index form to be able to differentiate. So if e.g. find the derivative of these functions below. So first up, f of x equals the square root of x. We can see that x is a single term, which is underneath a root sign. We want to change this to its fractional form, and this is easily differentiated by bringing that fraction to the front. So we get f dash of x, or the derivative, is equal to the half at the front, and the power goes down by 1. So half take away 1, that gets to negative a half. Now we like to obviously get rid of our negative powers, and we like to change our fractional powers back to their root sign form. So the idea is this negative power is going to go down the bottom. This denominator of 2 is on the bottom as well. And x to the power of a half is the square root of x. So this is your final answer. Next up, if f of x equals the square root of 5x, the easiest way to deal with this is to split this up into two terms, which are multiplying, which you can do with square root signs. So we get the square root of 5, which is just a constant. We can literally leave this out the front and not worry about it. And we can differentiate this part here. So differentiating x, the square root of x, so that's pretty much just what we did up here. That part, the derivative of this part here is going to be that, what we found before. So therefore, that can pretty much turn to, like, a derivative of this will change to that, and this root 5 will just stay out the front, and we can multiply this onto this for our final answer. So the root 5 is going to multiply by this 1, and we get root 5 over 2 lots of the square root of x as our final answer. A third one here, if we've got f of x equals 7 over the 5th root of x, we want to change this to fractional form, so we get 7 over x to the power of 1/5, which is equivalent to that. Then change this, because it's on the denominator, change this to negative index form. So instead of x to the power of 1/5, it's x to the power of negative 1 over 5. And the 7 stays at the front. We can differentiate this nice and easily. Negative 1/5 times that 7 gets us negative 7/5. And negative 1/5 take away 1, like it's going down by 1, it's going to get to negative 6/5. So that's just as an improper fraction. Like that negative 1 and 1/5 is that as an improper fraction. We prefer improper fractions. And finally, we want to get rid of our negative denominator by putting that x to the denominator. Sorry, that negative fraction, by making our x go to the denominator of this large fraction here. And then finally change this this fractional power to its surd form. So this 5 goes out, it's the 5th root, and the 6 is powering the x. So that is your final answer. Okay, so let's do some harder examples now. So differentiate this. This is a bit of a weird one because you've got that multiplied by that. The idea is whenever you see this root sign, you want to change it to its fractional index form, which is going to look like that. And we can add these powers because they have the same base. So that's going to be 3.5, because 3 plus a half, and change that to improper form. So it's going to be 7 over 2, and that is easily differentiable. So the 7 over 2 comes to the front, and it goes down by 1 to 5 over 2. So that's going to be your answer, but we want to change this to the surd form. So x to the power of 5 over 2 is going to be the square root of x to the power of 5. And we like to put that up with the 7 because it's multiplying. And the 2 is going to be just down the bottom. So that's your final answer. Question 2. Differentiate this one. This is a fair bit harder. We've got x's up the top and down the bottom. Notice that we've got x's down the bottom, but it's just a single term. So we can deal with that. With this 2 on the bottom, we want to change that to just a constant. That 2 down the bottom is like multiplying by 1/2. This 2 down the bottom is like that 2 right there. And this square root x on the bottom is like multiplying by 1 over root x. So it's pretty much a way of changing this so that there's, like, we pretty much want to get this out of the fraction. That's the idea. And these things are just going to be multiplying to accommodate, like to pretty much, like these have got to go somewhere. So that's where they've gone right there and now working. Once we've got to this stage, we can leave that half alone. It's just a constant. That won't affect the derivative. However, with this part here, it's got x's in it. We need to expand it with this. But firstly, we need to change it into so there's no denominator. We need to change it into negative index form. So that's going to be to the power of negative 1/2. And now we want to expand it with this other x part. So we expand it over here. Remember, when you're multiplying, your powers of x are going to add together. So negative 1/2 plus this power of 1 with the x. So negative 1/2 plus 1 is going to be positive 1/2, and the 10 stays put. And then this multiplied by the negative 6 is going to be negative 6x to the power of negative 1/2. And this part here, this bracket, is easily differentiated. And remember, this half is just staying put. It's not going to affect the derivative. So I'm just going to leave that half out the front. And now we differentiate this part. The half comes to the 10, and it becomes a 5. This goes down by 1, so it goes to negative 1/2. And negative 1/2 times negative 6 is positive 3. And this goes down by 1 to negative 3 over 2. Let's get rid of these negative powers and fractional powers as well. So this is going to be simplified to that, and this simplifies to this. Finally, you can put your half into each of these parts to get rid of these brackets. Half multiplied by that, our denominators are going to times together to give 2 lots of the square root of x. And half times this, it's going to be 3 over 2 lots of x to the power of the square root of x to the power of 3. Hope this helps with the questions. Good luck.